Alright, here we have e to the pi versus pi to the e. Which one is bigger? As we know, e is about 2.71 something and pi is about 3.14 something. However, both of them are irrational, so we cannot just compute it, right? And of course, we are not going to use a calculator, otherwise that would defeat this great question. And the way to do it is we have to somehow come up with a way to make a connection so that we can argue which one is bigger than the other. And at the moment, you see that the base and the exponent just got switched, right? So hopefully there is some kind of connection, and e and pi, they are both famous numbers in mathematics, right? And let me just show you, this is how I do it. And first of all, I would like to just kind of come up with an easier situation. And this is going to be my scratch paper. I'm going to just write down some thoughts right here. Let me kind of just change the question a little bit so that it's easier, and let's see if we can solve that. What if the question is this? E to the e pi power versus pi to the e pi power. Both of the powers are the same. Which one is bigger now? Well, we know pi is bigger than e. So if this is the question, then we know the answer. This has to be bigger than that, right? So that's pretty easy. But however, this is not the original question. I cannot just put on this and then say, hey, this is, we solved it, this is bigger, and then move on with the next one. I cannot do that, right? But now this is the interesting point I want to make. If we can somehow have the same exponent, the question seems to be easier, isn't it? But then I cannot just change the whole question. Let's see, I want to keep the same concept. I want to make sure that both terms have the same exponent, and then I still want to deal with the original expressions. So for the first one, let's say I want to have something to the e pi power. I still want to use that. And then the second one, I also want to have the same exponent. So let me write down the parentheses and then the e pi power as well. And now let me ask you, if I want to keep the same as the original, what should I put down inside of these parentheses? The answer for that is e to the 1 over e power. Why? Because when we have this raised to a power, we have to multiply the powers, right? 1 over e will cancel with this e, so altogether we have e to the pi, which is still the original. For the second one, what can we do? Well, I want pi here, and I want to put down pi to the 1 over pi. And you see that pi to the 1 over pi to the e pi power, this pi and that 1 over pi will cancel out. So we still end up with pi to the e power. Alright, so this is the original. And now they have the same exponents that the ones in the blue, right? But then I still don't see how we can say one is bigger than the other. However, here's the key. You see that we have e right here and e right here, pi right here and pi right here. This right here, we can consider a function. We can do calculus to argue which one is bigger than the other. Consider a function right here. Let's say x. And then right here is 1 over x for the power. They are in the same form. This right here can also be written as x to the 1 over x. They are on the same curve. And of course, there are different values, so I can label this as x1, x1, x2, x2. However, they are on the same curve, x to the 1 over x power. So that's how we're going to do it. I'm going to use calculus. I'm going to talk about the curve and then try to see if we can go from there. So of course, I'll write this down in black and red. And here we go. I'm going to consider a curve. Y is equal to x to the 1 over x. And then the strategy is I want to find the minimum or maximum of this curve and then try to see if that will help us out with deciding which one is bigger than the other. To find the minimum or maximum of a curve, we have to first find the first derivative. And then this is a function to a function power. So to find the derivative of this, we have to first ln both sides. So let me take the ln right here, and then let me take the ln right here. On the left-hand side, we just have ln y. And then the purpose of taking the ln is we can bring the power to the front now. So I will bring the 1 over x to the front, and then we have 1 over x times ln x. And then we can take the derivative. However, the y is not isolated, so we have to use implicit differentiation. So we'll do that right here. So let's look at this first. The derivative of ln y is first 1 over y, but then y is a function of x. So we have to multiply by the derivative of that, which will be dy dx. And that's the derivative that we need. On the right hand side here, this is the product of two functions, so we have to use the product rule. And the version of the product rule I want to use is, let me first keep the first function, which is 1 over x, and then we will multiply by the derivative of the second, which is going to be 1 over x. And then we add the second function, which is the ln x, and then we multiply by the derivative of the first function. The derivative of 1 over x is negative 1 over x squared. So this is the expression. But then we have to isolate the dy dx. We have 1 over y right here, so we just have to multiply both sides by y. So that this and that will cancel, and then we can get the dy dx by itself, right? This y is x to the 1 over x power, so we write that down, x to the 1 over x power, and then we multiply with this right here. This is just going to be 1 over x squared, and then this is a positive times a negative, so it's a minus, and let me put the ln x on the top, and then the x squared on the bottom. And then let me do one more step with you guys, because I see that they both have the x squared in the denominator, right? Let me factor that out. So let me write it down. dy dx is equal to x to the 1 over x times 1 over x squared. Let me write it down this way. Okay. So this right here will be 1, and this right here will be just minus ln x. I factored out the x squared in the denominator in the front already. So here is the derivative. We have to find the critical number first. We have to set this equal to 0, but then now we see x to the 1 over x power, it's never 0, and in fact always positive right here. Likewise, 1 over x squared, it's never 0, and in fact this is always positive as well. So let me just indicate that this right here is never 0. So in order for the derivative to be 0, we must have 1 minus ln x to be 0. And then we can just say this is 1 has to be ln x, and x has to be the number e. So this right here is the critical number. So let me just indicate that right here. Critical number. And do we end up with a minimum or maximum when x is equal to e? Let's take a quick look right here. Let me draw a number line, and then let me do the first derivative chart, dy dx. When x is e, which is right here, the derivative is 0. But then if x is less than e, what do we get? As we mentioned it, this is always positive. Pick a number less than e. Let's say it's 1. Then we have 1 minus ln 1. I plug in 1 into this x. ln 1 is 0, 1 is positive. So altogether, you have positive derivative when x is less than e. What if x is bigger than e? Let's say e squared. Then I put e squared into this x. This is always positive anyways, right? I put e squared in here, then we will have ln e squared, which is 2. 1 minus 2 is negative. So we have negative derivative right here after e, right? If x is bigger than e. So as you can see, the first derivative changes from positive and then 0 and then negative, right? We can say that there is a maximum at x is equal to e. It's a maximum point. So let me just write this down properly with you guys. When the x is equal to e, we know the function will have the maximum. So this means e to the 1 over e is the maximum value of x to the 1 over x. And then you see that now, this right here is this. And you know this is the maximum value of any form of x to the 1 over x. So we know that this right here has to be bigger than that, right? And now let me just write down the final conclusion. We know e to the 1 over e has to be bigger than pi to the 1 over pi, because this right here says so. And then we are going to raise both sides to the same power. Raise both sides to the e pi power. And then we can reduce to the original question, because this right here will give us e to the pi power. And then we still keep the same sign for the inequality symbol. And then this right here, we will have pi to the e power. And then we are done. This is a famous question, and hopefully you guys enjoyed it as much as I do as well.